Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL November 2021 paper 1. And today we will be solving the question number 12, that is the last question of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in the description area. So without any further delay, let us start answering question number 12. The maximum mark is 22 and the question says consider the equation z minus 1 whole raised to the power of 3 equal to I, where z belongs to the set of complex numbers. The roots of this equation are W1, W2 and W3, where imaginary part of W2 is greater than 0 and imaginary part of W3 is less than 0. We are having several subparts for this question. The very first subpart A, is again having two more subparts. I is verify that W1 equal to 1 plus e to the power of I times pi by 6 is a root of this equation. Okay, since this should be the root of this given equation, if it is a root of this given equation, then if we put this value in this equation should be satisfied by this value. What do I mean by satisfied? I mean that if we put this value in place of z, the left hand side of this equation, that is z minus 1 whole raised to the power of 3, should be equal to I. Okay, because if you have say 2x minus 1 is equal to 1. Okay? And I see that x equal to 1 is a solution for this equation or a root of this equation. Then if we substitute 1 in this equation, we get 2 times 1 minus 1 for the left hand side, which is 2 minus 1, that is 1, and we are having 1 in the right hand side as well. So whenever we are having the root given for an equation, if we substitute that root in the given equation, the left hand side should be equal to the right hand side. So let us test, let us substitute 1 plus e to the power of I times pi over 6 in place of z and let us see whether the left hand side becomes equal to I or not. Okay. So I start my answer from this part. This is z minus, I'm taking the left hand side. So z minus 1 whole raised to the power of 3 should be equal to 1 plus e to the power of I times pi by 6 or pi over 6 minus 1. Minus 1 is this, to the power of 3. And these two will be getting cancelled and we will be having e to the power of I times pi over 6 whole raised to the power of 3, which is equal to e to the power of I pi over 2. Okay? And what is e to the power of I pi over 2? This is equal to cos pi over 2 plus I sine pi over 2. Cos pi over 2 is 0 and sine pi over 2 is 1. So this is equal to I. This is the right hand side. Okay. And this is the left hand side. Hence, W1. So we are seeing that the left hand side is equal to the right hand side if we substitute this expression in the given equation. So W1 is a root. Proved. Okay. Coming to II. Find W2 and W3 expressing these in the form of A plus e to the power of I theta, where A is a real number and theta is greater than 0, and this whole subpart contains 6 marks. Okay, so I. We have got the W1. Let us first of all write this. I am just taking, I'm taking I. So I am writing Z minus 1 whole raised to the power of 3 is equal to I, and I is equal to, we have seen that to be equal to e to the power of I times pi over 2. So I am writing that. And next I am taking the cube root of both the sides, this one and this one. Okay. So therefore, Z minus 1 is equal to e to the power of I times pi over 2 whole raised to the power of 1/3. Okay, because we are taking the cube root. And this is equal to e raised to the power of I times pi over 6. Okay. So, and if we add 1 to both the sides, we will be getting this root z equal to 1 plus e to the power of I times pi over 6. Fine. So, first of all, let us keep z minus 1 as z minus 1 and let us get the 3 roots. Because it is a cubic equation, it will be having 3 roots. So, we have got the first root as e to the power of I times pi over 6. What are the other 2 roots? The other 2 roots are found by adding some factor to this pi over 6. If we add some factor to this pi over 6, we will be getting the second root. And if we add the same factor to the second root, we will be getting the third root. But what has to be added? We will be actually dividing this 2 pi. Why do we take 2 pi? Because if you think of the Argand diagram, we will be having Argand diagram in later subpart. So I'm not drawing it right at this moment for this subpart because we really do not need to draw that for answering this question. But you have to remember that if you draw the Argand diagram and the central angle that is covering the around the origin will be 2 pi or 360-degree or 2 pi. Okay. And that central angle will be equally divided into how many subparts? Into the number of roots that will be there. That means divided by the degree of the polynomial. Over here, the degree, it is a cubic equation. So how many roots will be there? 3. So we have to divide this 2 pi by 3. Because you will be having 3 roots lying on the circumference of the circle. In this case, the modulus is 1. If I take just z minus 1, so the modulus is 1, therefore it will be a unit circle. Otherwise, whatever is the modulus, that becomes the radius of the circle. So, over here, if we draw a unit circle, and the x-axis will be representing the real axis and the y-axis will be representing the imaginary axis, the first root will be located on the circumference. The angle will be pi over 6. And these 3 roots will be distributed on the circumference of the circle, of the unit circle, evenly. So what will be the central angle? What will be the angle between the 2 roots? Those will be distributed evenly. So there are 3 roots, therefore, and the total central angle is 2 pi. So we are dividing 2 pi by 3. This is the factor that we have to add. Okay. So we add pi over 6 because pi over 6 is our first root. Pi over 6 plus 2 pi, and these have to be written in the fair area. I'm writing over here doesn't mean that this should be written in rough section. No, these should be shown. Okay. So 2 pi by 3. This is equal to 4 pi over 6, right? I'm making the denominators the same. So this is pi over 6 plus 4 pi over 6, which is equal to 5 pi over 6. Okay. I can write this as, now I come to W1, because we are interested in getting the z values, not z minus 1 values. So W1 will be 1 plus, because this is d minus 1, W1 will be 1 plus e to the power of I times pi over 6. Okay. W2, this is actually z minus 1 is equal to e to the power of I 5 pi over 6. Okay. And therefore W2 is equal to 1 plus e to the power of I times 5 pi over 6. And now again, I have to add the same factor 4 pi over 6 to 5 pi over 6. So 4 pi over 6 plus 5 pi over 6 is equal to 9 pi over 6. Right? So actually, this is Z2 and Z3 minus 1. This is equal to e to the power of I times 9 pi over 6. Okay. But we are interested in getting the z value. So it is W3, which is equal to 1 plus e to the power of I times 9 pi over 6. So we have answered the subpart I and the subpart I completely. Let us move on to the subpart B. The roots W1, W2 and W3 are presented by the points A, B and C respectively on an Argand diagram. Subpart B says plot the points A, B and C on an Argand diagram and it contains 4 marks. Okay, and these were the roots. Z1 minus 1 is e to the power of I times pi over 6. Z2 minus 1 equal to e to the power of I times 5 pi over 6. And Z3 minus 1 is e to the power of I times 9 pi over 6. This can be written as e to the power of I and 3 pi over 2 as well. Okay. So, suppose Z minus 1 is equal to P. And we have to draw the points, we have to plot the roots of P equal to these three on an Argand diagram. So what do? Because the coefficient is 1, we will be having a unit circle as I've said before. So it will be like this way. And maybe I'm taking this one, and this one, this one. This is just a rough sketch. I'm drawing a circle so that I can at least have a roughly the same radius. Okay. So I'm drawing it. And this is for P. So one of the values of P is e to the power of I, 1 times e to the power of I times pi over 6. So this may be the pi over 6 angle. Okay. Second will be pi over 6. You must be knowing it is 30 degrees. So roughly this may be 30 degrees. Next is pi over 6. And Again, I am saying this is a unit circle and I am plotting the points for P. Okay. This is the real axis. This is the imaginary axis. And next it is 5 pi over 6. This is subpart B. So 5 pi over 6 is pi over 6 is 30. 30 times 5 is 150. So it will be like this. Maybe of this around this point. This whole thing is 5 pi over 6. Okay. And finally, it is 3 pi over 2. It is very easy, this one. Not arrow, but this is the point. So this whole thing is 3 pi over 2. Okay. So this is the Argand diagram if we were asked to get the roots of z minus 1. But W1, W2 and W3 are the roots of z, not z minus 1. So what is the difference? Difference is we are adding 1 to both the sides. Okay. So adding 1 to both the sides means what? If you have, say, if you have this, say, x equal to 5, or let me take a smaller number, x equal to 2, and I'm having a, this is the two real coordinate axis. This is 1, x, and this is y, and this may be 1 and this may be 2. So x equal to 2 is this line. Okay. This is 1, this is 2, this is 3. This way it goes. And now I'm writing another equation as x minus 1 equal to 2. What is the difference? You'll be saying that I'm adding plus 1 to both the sides. So it will be x equal to 3 and I'll be having a vertical line at the point x equal to 3. Right. But how can you interpret it geometrically? It is the horizontal translation of one unit towards the right. X, and then it is x equal to 2, and the next equation is x minus 1 equal to 2. So this is effectively doing what to the graph? It is horizontal translation is being performed on the graph. The graph is getting translated to the right by 1 unit. Clear? So the same thing is happening in this case. Since the horizontal axis is the real axis, if we add plus 1 to both the sides, what are we effectively doing? We are effectively shifting the graph by 1 unit towards the right along the real axis. Okay, because 1 is a real number. Okay, so that is what we will be doing. So if we translate the graph by 1 unit, this is the center point. Now the center of the circle will be coming to the 1 on the real axis. Before it was the origin, the 0. Now the center point will be of the circle will be equal to 1. That is the only difference. Okay. So now this was for P. And now we will be sketching for C. I could have taken the straight line shape for drawing the straight lines, but anyway. And this is the real axis, this is the imaginary axis. Okay, and maybe this is or let me take one, just a moment. Let me take one over here. Let me take one over here because it will be a unit circle. So fine. And I hope it is of the same length. Okay. This is a rough diagram. Okay. It is definitely not a circle, but, and you don't even have to draw a circle. I am drawing the circle so that the radius is almost the same. Though I'm very well seeing that the radius is not at all the same. Anyway, consider it to be the same. Okay. So this is, I have to draw, this is one. And maybe this is 30 degrees. This is pi over 6. This is 1. Okay. This is W1. Another is pi over 6. So it will be like this. I am writing this as 1 because obviously these lines do not have the same lengths. This is 1 and this one is pi over 6. This one. And the third one, it will be like this. This is 1. And the third one, it is like this. This is 3 pi over 2, 9 pi over 6 or 3 pi over 2. This is also 1. Okay. This is W1, this is W2, and this is W3. Clear? And they had said previously in the question that imaginary part of W2 is greater than 0. Of course, it is greater than 0 because it is above the real axis, and the imaginary part of W3 is less than 0. Definitely, you are seeing that because it is below the real axis. So, this is the Argand diagram. Okay. We have answered subpart B, coming to subpart C. Find AC. Okay. We have to name the points as well. So this is A, this is B, and this is C. So we have to get the length of this line segment AC. Fair enough. Fair enough. So let me just take another color. So we are having this line. Now I am answering subpart C, but since I have drawn this Argand diagram, I am not drawing it once more. I am considering this triangle. This triangle. This is a 1 unit. This is a 1 unit. And what is this angle equal to? It was equal to 2 pi by 3 or 4 pi by 6. That was the factor which got added. You see, pi by 6 plus 4 pi by 6 is 5 pi by 6. 5 pi by 6 plus 4 pi by 6 is 9 pi by 6. So 4 pi by 6 or 2 pi by 3 was the adding factor. Okay. So the three roots are evenly distributed on the circumference of this unit circle. And why is it a unit circle? Because the coefficient is 1. Okay. So this is 1, this is 1, and the in between angle is 2 pi over 3. Clear? Now we can, and if I just take this point as, what should I be saying? Let us take this as T. I'm considering the triangle ACD. Now let us use the cosine rule to get the length. So it will be subpart C, EC square equal to AD square plus CD square minus 2 times AD times CD times cos angle ADC. Clear? So this is equal to AD square is what? 1 square. CD square is what? Another 1 square. Minus 2 times 1 times 1 times cos of angle ADC is 2 pi by 3. So cos of 2 pi by 3. Okay. Cos pi by 3 is half. Cos 2 pi by 3 is negative half. So AC square is equal to 1 plus 1 is 2. 2 minus 2 times negative half. And this is negative 1 times negative 1 is positive 1. So it is 1, which is 2 plus 1, that is equal to 3. Therefore, AC is equal to root 3 units. Okay? We have solved subpart C. Let us move on to the next subpart. Consider the equation z minus 1 whole raised to the power of 3 equal to I times z to the power of 3, where z is a complex number, and some part D says, by using the de Moivre's theorem, show that alpha equal to 1 over 1 minus e to the power of I times pi over 6 is a root of this equation and it contains 3 marks. Fine. So, what we can do is we can write this equation in this form. Z minus 1 over z, because both are getting cubed, is equal to I. Okay. And what was I? It was equal to e to the power of I pi by 2, because cos pi by 2 is equal to 0 plus I sin pi by 2. Sin pi by 2 is equal to 1. So 0 plus 1i is I. So z minus 1 over z whole to the power of 3 equal to e to the power of I times pi over 2. This is equal to pi. Okay. So now we can just take the cube roots of both the sides. So we get z minus 1 over z is equal to e to the power of I pi by 2 whole raised to the power of 1 over 3, which is equal to e to the power of I times pi over 6. We have come to this portion, e to the power of I times pi over 6. So we are on the right track. Okay. So now we have to get the value of z. Means it is a cubic equation, so there will be 3 roots definitely, but they are asking for one of the roots which is named as alpha. Let us see which one is it. The first root or the second root or the third root. First of all, let us first find the first root. Okay. So z minus 1 over z can be written as c over z minus 1 over z, which is 1 minus 1 over z. This should be equal to e to the power of I times pi over 6. Okay. Therefore, 1 over z is equal to 1 minus e to the power of I times pi over 6. Okay. So this gives us the z value. We are taking the reciprocals of both the sides. Z value will be 1 over 1 minus e to the power of I times pi over 6. And this is equal to alpha. Okay, this is the very first root. So therefore, 1 over 1 minus e to the power of I pi by 6 is one of the roots of Z. Therefore, of Z or of this equation, let me write of this equation. Okay. Therefore, alpha equal to 1 over 1 minus e to the power of I times pi over 6. Okay. I have not boxed my previous answers, but okay, fine. Let me box this answer. Okay. Now we move on to the last subpart of this last question of this paper. Subpart E. Subpart E. Determine the value of the real part of alpha. And alpha was found to be equal to this 1 over 1 minus e to the power of I times pi over 6. So let us write that. Alpha equal to 1 over 1 minus, in place of e to the power of I over 6, I am writing cos pi over 6 plus I sin pi over 6. Is equal to 1 over 1 minus, now cos pi over 6 is root 3 over 2. So it is root 3 over 2, and sin pi over 6 is half. This is minus I times half. Okay. So this can be written as 1 over 2 minus root 3 minus I over 2, which is equal to 2 over 2 minus root 3 minus I. And of course, we have to rationalize the denominator. So I'm taking this 2 minus root 3 minus I, and I am multiplying the numerator and the denominator by 2 minus root 3 plus I. Okay. 2 minus root 3 plus I. So this is the whole thing. This whole thing will be getting multiplied with 2. So it is 4 minus 2 root 3 plus 2I over, this is A and this is B. Okay. A is 2 minus root 3 and I is B. Clear? So this is A minus B, and that is A plus B, which will be equal to A square minus B square. So it is 2 minus root 3 whole square minus I square. So this is 4 minus 2 root 3 plus 2I over, this is 2 minus root 3 whole square is 2 square, which is 4 plus root 3 whole square, which is 3, and minus 2 times 2 is 4 times root 3 is 4 root 3 minus 4 root 3, and I square is minus, so minus of minus 1, so minus of minus 1 is plus 1. Okay, so this is equal to 4 minus 2 root 3 plus 2i over 4 plus 3 is 7 plus 1 is 8. 8 minus 4 root 3. Okay. So now I can just separate the real part and the imaginary part. So it is, I can take out 2 from this. 2, and this is 2 minus root 3. And I'm taking out 4 from the denominator, sorry. It is 2 minus root 3 plus I times 2 over, say, 4, 2 minus root 3. Okay. So this will be cancelling, this will also be cancelling, and this will also be cancelling. So this is equal to half plus 1 over 2 times 2 minus root 3 I. Okay. Therefore, real part of alpha equal to is half. So this is our answer for the subpart E. So we have completed answering this question number 12 completely, and we have even completed answering the whole November 2021 paper 1. And thank you for staying with me till the end. I'm Nilanjana Sanyal, an online IB Math A, SL and HL levels tutor. I tutor both students from inside India and outside India. And if you find my solving of these questions uh, understandable, if you like them, please do give me a like and share these videos so that other students can also get benefited by watching my videos. And if you have any suggestions, please do feel free to write to me in the comment section. I'll definitely be going through them, and we'll be taking up the next paper, that is the paper 2 of this November 2021, from our next session. And as we are doing, we will be solving one question in each session. So till then, bye.